just make sure everything's up and running. But it's good to see everybody today. Welcome to the Cannabis Data Science Meetup group. My name's Keegan, founder of Cannalytics. We provide analytics primarily to laboratories, but really everyone in the cannabis industry. And it's good to see Charles and Heather, and then welcome Frank. So real quick, I guess Charles and Heather, would you mind introducing yourselves to Frank? And then Frank, if you wouldn't mind, you're welcome to introduce yourself to the group.
Hi, I'm Charles. I have a long history of software development experience, and I'm transitioning into the data science area now. I've been working on a lot of the Washington State data, trying to make some sense of it.
Awesome. Heather, it's good to see you today.
Howdy. Hi, everybody. I'm Heather. Not ex-scientist, but I've been in the lab for over a decade and then transitioned into QA, QC work. Now I have an interest in cannabis science, so what do I do with that? So now that's why I'm here.
Awesome. Well, good to have you as always. And
yeah,
Frank,
no, thank you. Like the invite.
Definitely. Frank, it's good to have you today. Would you mind sharing a bit about your interests and passion and what you may be doing for work?
Yeah, I work mostly on like back end, just kind of data management for some companies up in Washington in the cannabis industry, and so yeah, trying to sort out all the data sources that are up there and just kind of see what everybody else is thinking about in the data science realm. We'd like to use more data, but they don't really have the questions to ask. And I'm like, well, there's data around, but without questions to ask, it's kind of hard to do much with it. So,
well, you're in the right place because that's what we're always doing, asking questions and trying to get answers, or at least the best answers we can. Mm-hmm. And so we happen to be looking at a data set of lab results here in Washington State. So you can do a Freedom of Information request and get a data dump of all the observations that they have in the state traceability system. So you can do this with sales, you could do this with inventory, and then in our case, we've got all the data, but coincidentally, the lab results is one of the smaller data sets, and so that's one of the ones we're working with.
Yeah, cool.
Well, to, I think, jump right in, let me catch everybody up to speed with what we've been talking about. So I'll go ahead and share my screen, and then got some interesting observations for today. So right, and bear with me and just let me know if there's any lag or anything, and I'll do the best I can to make things run smoother. So long story short, we've been looking at lab results. We were needing some questions, so we started to look at other data or analysis that may have been done on cannabinoid testing or any sort of testing. And so we found this Midwestern hemp database where they've tested hemp. And what's interesting is hemp has a mandated federal limit of 0.3%. So as you can see in these charts, anything greater than 0.3% THC would actually be a failing hemp sample, and then anything below would be passing. And what we began to notice is the threshold, the limit, is set, in the middle of right in the cluster of data points. And so we were thinking that this may lead to situations where there's a couple things going on. One, you're going to maybe have misleading products. So something that technically passes at 0.29% THC that looks quite similar to a product that fails at 0.31% THC. So some of your conclusions about the data may be off. Also, just throwing in human incentives. This throws in a pretty, how should we say, there's a lot of, like, I guess, financial value tied up with this decision, this pass-fail decision. So it puts a lot of pressure on laboratories. So for example, the hemp producer that gets a test at 0.31% may call up the laboratory and try to pressure them and say, oh, hey, are you sure that this was really failing? And so, that's standard business. And so the laboratories, just need to say that, that's what we tested it at. But still, it creates that friction. And so long story short, it may not, we were thinking, is this necessary? Like, is this necessary friction? So would things work out okay if they raise the threshold to say 0.6, or I think there was talk about 0.65 or 0.7%. In that case, there would be a handful of samples that fail, and then, the bulk of the hemp is passing. There's not as much pressure on laboratories to misreport THC numbers. So we were curious about, what the effect is of having these thresholds at different levels. So that's interesting with hemp. We were wondering, can we apply this to research or to data in Washington State? And what Heather had brought up was, sometimes these oils may make it to the shelves and they may seem a little off. And so we were going to start looking at, okay, what are the regulations on these, say, residual solvents that may be in concentrates on a state-by-state basis? And so here are the data sources, and I'll post this code right after the talk. I don't want to press the memory too much right now. So long story short, here are the data sources where you can find the action limits. And so here, essentially, we've got the limits for Washington State, and I picked out this set of residual solvents, or this set of solvents, because these are the ones that we have data for in Washington State. A lot of these states test for more residual solvents, and as you see, some test for less. And Heather, this is where I was thinking that I had you in mind, was, you're here in Maryland, and Maryland actually has one of the least stringent testing regimes that there are. So they only test for, a little more than a handful of solvents. Whereas, so for example, some, like in Washington, they'll test for acetone, and I don't believe you test for acetone in Maryland. And so there's variability here. And from a data science perspective, wherever you can find variability, you can typically do an interesting analysis of some sort or the other, because that's what makes things interesting. It is the differences and the variability. So
one thing, you have heptane in there twice.
yes,
It's
so
heptane and heptanes.
exactly. And so you may have seen this in the data, and we may need to do a deeper dive here. However, okay, so I've read in the data over here. As Charles has pointed out, not all of these are valid observations, but I'm curious here. If there's just two, okay, so see, it looks like there's two fields here in the Leaf Data Systems traceability data set. So I think you can enter in both heptane and heptanes. And I think the rationale may be that there are heptane-like compounds, which are your heptanes.
Isomers.
Yeah, exactly. So your isomers.
You may not be able to distinguish between those isomers, so they'll conglomerately heptanes, like a hot dog, like this is what we think it is.
Exactly. And so this may be one of these situations where we may not have entirely consistent data entry across the board. And so this should be something that should be noted. However, we've got the data, and one of my philosophies is never throw away any data. So we'll keep it and work with it. And for the most part, I've just double coded heptane and heptanes. So if you look at the various regulations, some of them, like the Canadian limits, specify the isomers, whereas others are less specific. And so when you have time, it wouldn't hurt to read through some of the regulations here, where you can start seeing how they vary by, well, this is by country, but by country by country, by state. And here you see, for example, they have, so for, like in Washington State, we test for isopropanol. And I believe, I'm not a chemist, so this may not be factually correct, but basically I believe isopropyl acetate is, like Heather said, either an isomer or related in some manner to isopropanol. So for Canada, I used their limit of 5,000. So not entirely apples to apples, however close. For the most part, they're testing a lot of the same compounds. So your pentane, your propane. However, there are differences. So for example, I couldn't find a state that's testing for triethylamine, unless this is an isomer of some sort, or nitrogen either. Well, actually, it says there's no limit. So some places test for more, some test for less. And so this is where we were talking about, be careful what you measure. Because so in Maryland, they're not even measuring acetone. So this is where I was talking about, you may have something that gets stamped as pass, but it may have residual solvents, just not the ones that you were testing for. So that's sort of where the discussion is leading. So just to kind of get right into the juicy bits, because we've got some real interesting observations here, and I'm interested to hear everyone's take and see if there's some new leads we can take, some new ways we can go with this. So next things next, just was going to look at, okay, so given that we have different limits in different states, are there any samples that say may pass in Washington, but may fail in another state? And so the states that I've currently been working in are as follows. And so basically, Washington State, we want to compare. And so I'm curious, okay, well, how does that compare to Oklahoma? So Oklahoma has slightly newer regulations, and it will be interesting to compare. And then Florida, which is medicinal only and is anecdotally has strict regulations. So it'll be the first time I've run this for loop. So let's hope. Here, let's actually add a line break in here just to kind of help us see what's going on. Okay, so okay, so I think I actually need to simplify this for loop, because right now I'm actually looping over all the concentrate types and all the analytes. So right now, let's just look at any of the sample types and just look at that. So let's try this for loop out, and maybe this will be slightly simpler. Okay, so this is a little better. Okay, so what's going on here is essentially, okay, how many failures for acetone were there in Washington, Oklahoma, and Florida? So Washington is the real. So there were, 7 real failures for acetone in Washington. If we were under the Oklahoma testing regime, then there'd be 28 failures. And then in Florida, there would be 46. And so then if we just go down the line, and just so you know, I've just looked at the acetone numbers. And so this is new information to me. So it appears that, so this is quite interesting. So look, so benzene, the same in Washington and Oklahoma, quite a few more failures in Florida. They're not measuring chloroform in Oklahoma. I would like to look into the coding of this because this is such a large number, but it looks like there is a substantial amount of samples that would fail for dichloromethane in Florida, whereas you'd only have 1 failure in Washington State. And so I think this is worth the drilling down on. So like, what is going on with dichloromethane? Is this just some sort of miscoding of some sort? So okay, so they're not testing in Oklahoma. And so, yeah, so look at this. So they allow 600 parts per million in Washington, whereas they only allow 2 parts per million in Florida. And I'll, in fact, even want to kind of double check just to be 100% certain that I coded this in correctly. So I may do this on my own time rather than hold you up here. But anywho, exactly. So look here, dichloromethane, 2 parts per million or less. And so, I mean, that's a staggering difference, right? So in Washington, they're allowing 600, up to 600 parts per million, and then in Florida, 2. And so what's the effect of that? Well, the effect is almost 5,000 samples would have failed in Florida that made it to the shelves in Washington State. And so, that's I think for people to investigate further, like, are Florida's restrictions too strict? So, hold on, is my connection still okay here?
I can hear you.
Okay, great.
All
So,
good?
okay, for some reason I just thought the connection may have not been 100%. Ah, here we go. We have Paul. So, okay. Welcome, Paul. So, I thought I may have heard someone trying to get in, so it's
Yep.
good to have you.
Sorry about that, Keegan. Yeah, thank you.
Oh, by all means. So just to fill you in, so I'm sure you may have noticed, so in the past few weeks, we've been talking about the residual solvent limits. And so we've now broken them down. And so now we're saying, okay, what are the different limits for the various analytes in the different states? And right now, we've just uncovered our first major difference, which is dichloromethane, which they don't have a limit for in Oklahoma, to my knowledge. And and the limit is, 600 parts per million in Washington. And so, if you'd applied that, you have almost 5,000 samples that would have failed. And so I think this may take a little more time. So Charles or Paul or anyone else who wants to dive into this, I think it would be interesting to look at these 5,000 samples and find out more about them. Like, what types of samples are those? Are they located in a specific place in the state? Oh, but essentially, what's going on with those, or then this is where there's even opportunities. So Fred, or Frank, this is where you could potentially provide value. So you could look at the licensees that have this dichloromethane in their products. And I mean, it's public information. And so you could, reach out to them and say, hey, I've been looking at the Washington State data of residual solvents, and I've noticed that, your products, have a level of dichloromethane that wouldn't be permitted in Florida. I just thought I would, let you know in case you were thinking about expanding into Florida or something of that sort. And so, there may be processors that they may think their operation is picture perfect, but it just may be permissible under the Washington State limits But if they were to say try to operate in another state, they may have difficulties. So for example, say a processor in Washington tries to go set up shop in Michigan or in Maine, they're going to have trouble, or they potentially could have trouble if they're used to having high levels, or, high is subjective, but if they're used to having levels of dichloromethane in their products. Conversely, someone in Massachusetts, they may be even more accustomed to having dichloromethane being permissible in their products than in other states. I think Colorado is pretty strict. And then it looks like California is also strict. They're even stricter than Florida. They have 1 part per million of dichloromethane. So I think these are interesting observations here. And so this is the first that I'm seeing the data. So you're seeing it with me. And so honestly, I wasn't even sure if these numbers were going to be different. And so, Charles, this may be something that you may want to expand your prediction analysis with, because so remember we were saying like, oh, there's so few failures in Washington State that it may be hard to predict the failures. Well, here you could say, okay, there's almost a 0% chance, or there's a low, negligible chance that you'll fail for these solvents in Washington. But if you're in Florida, there's definitely a higher probability of failure. So once again, you could calculate those statistics and then reach out to, say, a license, and then you could make it conditional on licensee. And so you can say, oh, hey, licensee X, you've got this probability of failing for residual solvents in Oklahoma or in Florida or in California or Colorado or where have you, because Washington State has interesting rules where I don't think you're allowed to have a lot of cross-state operations. I may be wrong on this, but people have long future plans. And so if there were a processor in Washington State, and they are thinking about expanding into another state, like they would probably, I think, they may benefit from dialing in their process ahead of time. So if they can realize, oh, I'm not really failing for isopropanol in Washington State, but I would in Oklahoma, well, it's time to dial that in. Ooh, and I think, so we've established that there's differences here. And so let's look at this data. And so because I think I've done enough just pointing at numbers that just actually plotting these would be worthwhile here. Okay, so what am I doing here? So I'm iterating over the solvents, which we've defined here, which is everything from acetone to propane. I'm getting the observations that have detected that analyte. So these are the observations where you have measured, say, acetone, or you have measured benzene, or what have you. And then I'm also restricting it to anything that's less than 20,000 parts per million. The reason I'm doing this is the failure rate for most of these compounds, I believe, is 5,000, maybe 10,000. And so anything way above that is definitely going to be a failure. And I've noticed that there may be miscodings or potentially just ridiculously high level concentrations. But I think they're miscodings where people have just miscoded high, say 100,000 ppm of solvent. And so, long story short, just sort of putting a cap on the data. So, and then just plotting them with the limits. So for each plot, I'm going to add the limit. And I'll post this code to GitHub afterwards, so that way people can follow up on the analysis. And so these charts just generated for the first time right before the meetup, so they'll be interesting to look at together. So just starting from the top here. So here they've essentially plotted everything that's tested for acetone in Washington State between early 2018 to the end of 2020. And so this excludes anything that did not have acetone detected and excludes anything that was not tested for residual solvents. So you could expect that these are concentrates of some sort that had some level of acetone. And so this is supposed to be reminiscent of the plot we saw with hemp, where we were seeing, okay, where are the limits set with hemp and what proportion of the samples are failing. And so this is where I think things just start out interesting. So here you see, okay, Oklahoma and Florida have a similar limit. And then the Washington State limit at 5,000 is, substantially higher. And what is the result of that? Well, the result is there's a handful of samples here that make it to market in Washington that wouldn't make it to market in Oklahoma or Florida. And this is where I think things, they become worth thinking over. So, Washingtonians may want to, take a look at things and are they okay with, this proportion of samples making it to market with acetone? So this is where we talk about the cost benefit analysis, right? So if you lower the limits too far, then, well, I mean, it's subjective, right? So maybe consumers think the limit for acetone should be 0 and all of these samples should be failing. But then that would be thousands of thousands and thousands of grams of oil. And so that would be a huge cost to the processors. So, the idea is, okay, what is the permissible amount? And, from my economics point of view, I think it comes down to the cost benefit analysis. However, everybody has, their own, their own stake at this. And so just to move through here, unless quick, does anyone have any questions, or is everyone following along pretty well so far?
So I still have a lot of issues with this data from, I sent you that report. And there's actually probably two sets of data, right? There's a whole bunch of data at the beginning of 2018, actually all the way up to like September, which doesn't seem like it's valid data.
Yes.
You know, it's like 3/4 of the data, but it has a 0.07% failure rate. And then there's this other set of data that has like a 4.5% failure rate that, you know, it seems like it's more consistent. I mean, obviously some things changed, and obviously there's a lot of historical data that was crammed into the beginning of 2018, and I think this really clouds the results. And as a mathematician, this kind of like really makes me twitchy.
Yes. And so I think it's an interesting observation, and it's tough to approach, right? So, right, we were talking about earlier, you know, never throw away data. So we hate to just throw it away. At the same time, it's suspect, right? There's something, like you said, there's miscodings or whatnot. And then the reasonable explanation is, so right here, this was the transition to the Leaf data systems. So there's just a lot of just things just getting coded in. And so that would just be like existing inventory that gets added in.
But it's a lot of noise. And I mean, if you don't throw away all this noise, then you kind of just have a bunch of noise clouding up your predictions. And, you know, if you're trying to use any sort of data science techniques or machine learning techniques, your results are invalid because you have all this noise. You can't learn anything. You can't actually see what's going on because there's so much noise covering the signal.
Ooh, and I think you've hit on a good point. And so I think it may be worth trying to exclude some of the noise. So, for example, like that's what I was starting to do here with excluding things below 0 and above less than 20,000. So this is nifty because so in these plots, we're just looking at things that tested for acetone. So this is throwing away, hopefully, a lot of the noise. So this will be excluding everything that doesn't have acetone. With your analysis, you're going to have to do a bit more legwork to figure out what to exclude and how to do your analysis. But I think you're right. So I think for starters, you could potentially time restrict it. So, okay, let's just look at things past 2019. That could be a starter, or just look at things past 2020.
Or even just filter out. See, it's kind of, there's a lot of, there's a couple odd things going on. I mean, you could filter out everything that doesn't have a valid lab ID. That's one thing, because there are results that have valid lab IDs that start in February of 2018 and go all the way through 2021. But there's that other thing that the intermediate type, there's a lot of activity at the beginning of 2018, and then it basically drops off to being reported at 0. And then all of a sudden in like July of 2019, it pops back up and it's in every result.
Yes. And so that may actually be the better breaking point. So basically what happens is Leaf data system gets adopted in 2018. They give everyone a lot of leeway for entering in their historic inventory. And so they give them really through April of 2018, but then I think they still gave them a bit of leeway. So you're looking at all the way through April of 2018 just for data to get entered. Then there was a major it wasn't, in my opinion, that major, but there was an update that occurred in July of 2019, and it was actually kind of a shock for the industry. In one of the earlier meetups, we were talking about, oh, there was a great metric outage in California or wherever, apparently. And so this would be the equivalent in Washington State. So for about a week in July, or about a week or 2 weeks in July of 2019, there was an update. And what happened is, okay, so that essentially broke the API changed a little bit. And so a lot of the software systems were no longer compatible. And so there was a lot of software problems. People had to update their software systems. And so there was a lot of noise in the industry. And so there was a period there where you have bad data entry. So they basically, Washington State permitted attested lab results where the licensee could attest that their sample had been tested, and then that they could enter in the results. And so you have just a period there where there are odd results and inconsistent data entry. And so that could even be this period here.
Right, and I think they squeaked in a lot of things because there's sort of, like it averages out about 200-300 entries a day, and then there's this couple day period where it spikes to like 6,000 entries. So they probably had a bunch of failing product, and then they attested, oh, it passed.
Yeah. Well, I don't necessarily know about that, but you see, like here, there's this line here.
Yeah.
So there's a handful of failures, but that's basically maybe, oh, they couldn't do data entry, and then they just did all their data entry on one day. So
Right. So yeah, I think anything after that seems to be valid. I mean, everything else behind that seems really noisy, and there's the intermediate type is missing for like months on end.
exactly, and this is where you could do some justification. You could hunt down the press releases that Washington State put out saying, oh, we're doing updates to the traceability system. And then you can just provide some rationale for, okay, we're going to restrict our data set to, August of 2019 and onwards. Or even just give it a bit of leeway and just say, okay, we're just going to restrict this from 2020 onwards, just so we have a, a reliable data set here. So I think you're definitely onto something, Charles, and I like how you're not satisfied with the messy data, and you're striving for top-notch analytics, and so that's what we're all about here. So just to bring it home, just to kind of show you some of the other charts here. So you've got your charts like benzene, where everybody is essentially failing at anything that has benzene. And then here I'm looking at this essentially brand new with you. And so this is where we run into this situation where this is similar to the hemp database we were looking at with failing hemp for high THC. And so here we see this line where, yes, it looks like a lot of things were entered all at once. And so the situation here is, okay, so the limit is 5,000 parts per million in Washington. And so, you have, a non-negligible portion of the samples failing for butane. Florida's limit is actually slightly higher than Oklahoma. So, but look here at Oklahoma's limit. So Oklahoma has pushed their limit low. It is 1,000. So Oklahoma has a limit for butanes of 1,000 parts per million. and then Florida has a limit of 2,000. And so and this is just drilling home the point where, okay, if you're operating in Washington, you may be used to having, 1, 2, 3, maybe even 4,000 parts per million of butane in your final product, and it still be permissible to be sold. And this is where I was saying, people aren't diving deep into this. Well, I mean, some are, but if you get a certificate of analysis and it says pass all across the board, retailer may not think twice, and they're just going to put this on their shelves. They're just looking at their certificate. They're looking for it to say pass or fail. If it says pass, it's a go. If it fails, it's a failure, right? And so, you're seeing products here that may be like 4,900 parts per million, 4,700 parts per million, real close. And so does a retailer necessarily want those on their shelves, right? Because say maybe a retailer has a policy, right? So maybe a retailer has and once again, I'm not certain about the cross-state ownership here, but maybe, a retailer operates in multiple states. Well, maybe they have internal quality control standards, and so they say, okay, we don't want anything with more than 1,000 parts per million of butane in our store because, okay, that's not allowed in Oklahoma, so maybe we shouldn't allow that in Washington. And so then they'll have to actually look at their certificate of analysis and see that, okay, what is the level of butane? So, and then this is where the dialogue with the public comes in. Was, okay, what is the permissible level of butane? So do consumers care about this? Like, are they okay with this in their products? What's the science behind it? So what is the effect of consuming 100 parts per million of butane in your 1 gram of oil? Like what is the effect of that? Like, is that a negligible amount of butane? Is that a non-negligible amount? So I think these are questions that are worth being looked into. So, and then just to show you some of the other charts here, chloroform, cyclohexane. Would like to do a deeper dive on this, but so this is one that's interesting where this is not a good compound that you probably would not want in your system. And there's are things with detections of cyclohexane, but these are making it to market. And then here where we talked about dichloromethane, where you see many samples failing in Florida, whereas you really don't see many samples, just a handful, if any, failing in Washington State. Similarly, this is ethyl acetate. You see just a couple failures in Washington State, and then you see if these were tested in the Oklahoma or Florida testing regimes, then you would see, oh wow, there's and keep in mind, I don't know the weight exactly, but this, one sample represents a substantial amount of oil or concentrate that's going to be sold to the retailer. So this this adds up. So if these were failed, that would be a cost to the processor. And then otherwise, they could be a health risk to the consumers if they do make it to market. Heptane. And really, what these charts are really showing is, I didn't realize this until creating the charts, is that Washington State has fairly permissible residual solvent limits. So, and this is where we were talking about how really states that are coming online sooner or more recently are almost leapfrogging some of the existing states. So basically, okay, when Washington set their regulations, everyone was just setting the bar at 5,000. So they set their bar at 5,000. And then, somebody came along and then, Canada set their bar even lower. Or, New York set their bar low. Or who have you. California came along and they set their bar low. And so then the next state that comes along, well, they're just going to look at, okay, what are the existing regulations? And often they adopt the more stringent regulations, because the policy, the person in charge of public policy, they have the public's health at their principal concern. So, they don't want to risk these products necessarily making it to market. So they'll often opt for the more stringent regulation. And just to finish it out here are heptanes. So this is where we're talking about coding. So it looks like really people aren't coding in heptanes. So it looks like heptane is the principal analyte that people enter.
I think heptanes is a depreciated column.
Okay, that's what's going on here. And
Yeah.
so exactly. So it looks like here in July of 2019, it gets deprecated. So that's good information. So exactly. So just focus on heptane. And then hexanes, once again, where you have Washington permitting these samples, whereas Oklahoma and Florida would not. And keep in mind, from what I've heard, Florida is quite strict. Oklahoma, I don't know that much about, but it's interesting to see that they apparently have a bit more stringent regulations than Washington, as far as the actual permissible amount of solvents. Ooh, and so this is an interesting one. So this one's isopropanol. And so isopropanol alcohol is used for cleaning. And so once again, people in Washington, they may be used to having standard operating procedures that include the use of isopropanol alcohol, and this may wind up into their products. If they were going to go set up shop in another state, they may need to address their standard operating procedures to make sure that they're not contaminating their products with isopropanol. Methanol, definitely don't want that in your products. And so, you're starting to see, the consensus being lower. And keep in mind, I just picked out Oklahoma and Florida as on a win here. And so I encourage you to, why don't you, repeat some of these charts with some of the other states. So, okay, why don't we look at California and Colorado? Or Heather, why don't you look at Maryland? Or Paul, you could look at Michigan. So it would just be interesting to see, okay, what is going to be allowed state by state. And then just to show all the charts, pentanes, similar story, propane, once again, you're seeing the Washington limit being quite high. And once again, what is high? So that's where the dialogue comes in. All we can do is present the data, and then cultivators, processors, regulators, consumers can have it, they need to have a dialogue and discuss, okay, what are the permissible levels of these solvents that are going to be allowed in concentrates. Polyolene, toluene, xylenes. Definitely don't want those. And so, and here, the Washington state limit is, it is catching most of them, but there are a handful that still make it through to the market that wouldn't be allowed in Florida or Oklahoma. And there we have it. And so that was the analysis that I prepared for today that sort of builds off of what we've been talking about. And, that was in vein of what we were talking about with the hemp database, where we were saying, okay, why don't we redo these charts with residual solvents on the x-axis. All right. And so just to take it home here, I've done a lot of talking today, and so perhaps next week we can have a bit more of a back and forth dialogue, because it's a meetup group after all. We're supposed to be talking. So sorry for just stealing the stage here. So what are your thoughts? Was this analysis you found interesting, or what have you?
Yeah, I thought it was interesting, Keegan. It's I always keep thinking about market consolidation, which will happen at some point. And to be able to know all these different thresholds for different states, any big players that come onto the scene that want to start consolidating, they're going to have to understand all this. And I'm wondering if a strategy for somebody like a big investor would be not necessarily to expand a chain of labs, but just to go, because the labs that are in their separate states have already fitted to the standards that are in place. If they would just go in and try to buy up a bunch of labs, and then make a chain out of all their purchases, instead of having to learn everything on the ground level at each state, just buy up the knowledge.
Well, so there are variations from state to state. And so, for example, like in Oklahoma, Michigan, you've got mandated pesticide testing. Don't have that in Washington state. However, the chemists, the ones that are doing pesticide testing, it's more just like, okay, which pesticides are there? So just, give us the list. We'll test for them. So most of the laboratories, they have their own levels of detection, which are much lower than the limits. And so to me, I just see it as just, okay, just what the limit is. So they'll just still test for the same pesticides and residual solvents. And then this is where we were talking about, they may need to add analytes state by state. So there will be some learning by doing in some places. So for example, places with an extensive pesticide panel. So say you're in California and you've got 70 plus pesticides. Somebody operating there is going to be much better probably at testing pesticides than somebody in, say, Oklahoma. And I think in Oklahoma, they have maybe a dozen or 2 dozen regulated pesticides. And so, the method development manager there is, they may not have been forced to do as much development. And it gets tricky when you start to, so in Canada, they may have 100 plus, maybe 120 plus regulated pesticides. And when you start to have to test for 120 pesticides, it becomes tricky because you almost need two different scientific instruments to really measure them all. So I think you're right. There will be some people who are experts at certain things in some states. So
it's going to be interesting to see how it shakes out over the next couple of years. That's for sure. But your analysis was really cool.
Exactly. And there's going to be a lot of hard feelings one way or the other, because
Right.
like I said, like in Washington State, they've got those limits set at 5,000. And if they were going to change those, there would be so much noise in the industry, like all the processors. And that's just public policy. That's what takes place. And there would just be, the deliberative dialogues. They say, okay, we think we should lower the limits. The processors are going to say, we don't think you should lower the limits. And then they'll have their back and forth, and they'll settle on something. And so that's why, as you said, if, say the federal government were going to come out with residual solvent limits, I think there'd be a big dialogue between all the parties involved as, okay, what are these limits going to be?
Yeah, I wonder if some of these more, well-off labs are going to start hiring consultants to go lobby in the various states, right, for their interest. It's going to be interesting to see what happens.
Well,
Thank you.
Definitely. And my only point there is, it's an interesting thing. So the labs want to test for it, right? So the lab says, oh yes, I think we should test for acetone. But the lab may not necessarily want a 2 ppm limit on acetone, because if they're having to fail 30% of the samples, then that's a tough conversation you have to have with the processors. So I think the labs are in the situation where they probably want to test for it, but I don't know if they necessarily want the lowest limit possible.
Yeah, this, as you always say about cost benefit analysis, right? There's going to be a lot of that going on, I'm sure.
Yes.
So yeah.
So
anyway, cool stuff.
So interesting topic. Thanks everyone for coming. I hope you got something out of it. And so definitely feel free to, shoot any messages throughout the week if you have any ideas or have any avenues for further research.
Sure. And just Keegan, real quick, I'm shooting to have my full paper completed this weekend.
Awesome.
So
yes.
If I get that done, I will forward the entire thing over to you this time.
Nice. And I have a review that owed to you, and so thanks for bearing with me. And so
yeah, don't worry about it. Don't kill yourself over that, please.
But it's coming. And so everybody, stay tuned. I'll try to get the video uploaded so that way you can review it and see anything. And then let's all stay in touch, and we can pick this back up next week and look at some more data.
Take care, everybody.
All right, have a productive week.
Bye.
Bye-bye.
Bye now.